What is going on, guys? Welcome back. In this video today, we're going to implement a full comprehensive project from scratch. We're going to build a backend in Python using FastAPI and a frontend in React and TypeScript. And we're also going to test our API before we connect it to the frontend. It's going to be quite a comprehensive, as I said, and interesting project. We're going to build a crypto tracking tool, or you could also say a crypto demo portfolio. The idea is we can add fictional money, so fake money to play around with. We can buy and sell cryptocurrencies, and we can track the progress so we can see what would have happened if we were to do this on the actual market. So the market data is going to be real market data, but our money is just going to be fake money, play money, so to say. And this project is useful for you if you want to play around with that, if you want to customize your own demo portfolio, but also if you just want to learn how to code an actual project, including backend and frontend. So let us get right into it. Alright, so we're going to learn quite a lot today. We're going to build the full FastAPI backend. We're also going to connect to a database, so we're going to use EchoAPI. We're going to use a frontend, so we're going to touch on React and TypeScript. I will say right away, we're going to use Cursor for the frontend because I don't want to type all the frontend code from scratch. We're going to use generative AI to do the frontend for us, but we're going to still explore the interesting parts where we actually communicate with our API. And we're also going to do API testing. We're going to see how we can use our API if we implemented our API correctly before we use it with the frontend. And for this, we're going to use EchoAPI. Everything that you see in this video today is going to be free and reproducible, so you don't have to pay any money for it. You can follow along and build everything here on your own system without having to do anything special. So let us get started. I'm going to open up my terminal. I'm going to navigate to my current directory, which is my usual working directory. Here, I'm going to remove everything in case something is still here. And now I'm going to create a new directory here, which I'm going to call backend. So I'm going to say make directory backend. And this is going to be our FastAPI backend in Python. And in this backend directory here, we're going to have a models file because we're going to have a database schema that is going to represent the structure of our data. So we're going to have users. Users are going to have portfolios. We can add money. We can buy stocks or actually crypto. We can sell crypto. We can see the performance and so on. All of this is going to be implemented here. But for this, we need a models file with SQLAlchemy. We're going to have also the routes. So the main endpoints that we're going to target since we're building an API, and we're also going to have Pydantic schemas so that we have validation of input automatically with Pydantic. So you're going to learn a lot. You're going to learn Pydantic, you're going to learn SQLAlchemy, and you're going to learn FastAPI. Of course, it makes sense to have a little bit of knowledge already, but I'm going to try to keep it beginner friendly and to explain everything here, not necessarily from scratch, but I try to explain everything that could be confusing. So the first thing we need to do is we need to install the packages that we're going to use. So either use pip, or if you're comfortable with it, you can also use UV. But let's go with pip since that is quite mainstream. Pip or pip3 install. And we're going to install FastAPI. We're going to install SQLAlchemy. We're going to install, I think JWT is also an external Python package. So that is going to be installed. And besides that, also requests, since we need to get the data from the Binance API. And I think other than that, just Pydantic, that's it. So FastAPI, SQLAlchemy, JWT for the authentication, requests, and Pydantic. And now we can clear all of that and we can create a directory, actually not directory, sorry, we can create a file called models.py. I think it makes most sense to start with the idea of what we want to do here, and we're going to model this using SQLAlchemy. So let's start with the imports. We're going to say from SQLAlchemy, we want to import column, obviously, integer, string, so just the basic data types, float, foreign key for relationships, and date time to have the transactions that we make so that we can see, okay, what has happened in the past, how is the performance of this portfolio. All right, then we're going to also say from SQLAlchemy.orm, we're going to import relationship, and then also from SQLAlchemy.extension.declarative, we're going to import the declarative base, which is like the meta class here for the class-based version. All right, so we're going to create this base. We're going to say base is equal to declarative base, and then we're going to create our classes. And these classes are going to be the following. We're going to have users. So a user has an account and a user can have a portfolio and he can buy and sell stuff. So the user is going to inherit from base, and the user table name, we want to set this manually here, is going to be equal to users, plural in the database. And then we need the primary key, let's call it ID, which is going to be a column of data type integer. Primary key is going to be equal to true for this one. And also index is equal to true. So we have fast access to it. Index basically means that the access is optimized because we have an index based on this feature. Now we're also going to have username. The username is going to be a column of type string. And it's also going to have index equal to true and unique equal to true. So it's not a primary key, but it's unique, which means that you can only have the same username once. Password is going to be equal to column string and nothing else, because we don't need an index. We don't need uniqueness, obviously. And then we're going to say portfolio is equal to, let's say, pass for now, because we need to implement the portfolio class. So the idea is one user owns one portfolio. So basically a user owns a portfolio is owned by a user, and we can model it like this. We can say class portfolio with a capital P, of course, inheriting from base. Table name is equal to portfolios. And here as well, we have an ID, column, integer, primary key equal to true, index equal to true. And then we want to have a user ID. So who owns that portfolio? That is going to be a column of type integer, and it's going to be a foreign key to the user. So it's going to be to users ID, like this. So this means that this portfolio has a reference user ID, which points to users, this table here, .id, so to this field. That is the owner of the portfolio. Then we're going to say total added money, or total money added. I'm not sure what the correct way is. It's going to be a float. The default in the beginning is going to be 0. In addition to that, we also want to have a available money column, which is the same. And then we also want to have here down below for SQLAlchemy now, the relationships. This is important because of course we can have a user ID, but we also want to have a user object that is related, so that I can just in Python say portfolio.user, and I can get the object here from user. So I can say user is equal to relationship, and I can say relationship to user like this, back populates portfolio. What this basically means is that from portfolio, I can access the user object. From user, I can access the portfolio object. That's the same thing. And now we can go up here and we can say portfolio is relationship, portfolio, and then back populates user. And then we can say useList is false. All right, and then we need two more classes. We have a portfolio, we have a user. Now in the portfolio, we can have assets. So let's add these two here. Assets is pass, and then also transactions is pass. The reason we want to have transactions is because we want to see how the performance is. So we want to see, okay, how much money have you made or lost, not just how much money do you have right now. So the worth of the portfolio over time, essentially. So class and asset is going to be the next class here, and it's going to have the table name, assets, not surprising. It's also going to have an ID, not surprising, type integer, and primary key, and index. There you go. And here for the asset now, we want to have the portfolio ID. So what kind of portfolio, or which portfolio does this asset belong to? So we're going to say portfolio ID. And now you know how this works. Column integer, foreign key, and then portfolio dot or portfolios dot ID. And then we also want to have some fields for the asset. We want to have the symbol, for example, BTC for Bitcoin, which is going to be a column let's say this is of type, or not let's say, it has to be of type string. I mean, you could also say it's an enum if you have a list of certain symbols that you want to allow for, but let's say it's column string, and then we want to say quantity is equal to column integer. Or actually, we can make this a float because we can have, 0.3 Bitcoin as well. And finally, we also want to have the relationship here. Portfolio is equal to relationship. Portfolio back populates assets. Now, this is important. This time it's assets because we have like a one-to-n relationship. One portfolio has multiple assets. One asset belongs to one portfolio. So yeah, that's important. We're going to also say here relationship, and we're going to say asset back populates, assets is equal to relationship asset back populates portfolio. And finally, we have our transactions. The transactions are going to be the last class here, transactions. And then we say, guess what? We want to have a table name and an ID. I'm going to just copy this now. So this is going to be transactions. The ID is going to be the same. We also want to copy this here, the portfolio ID. It's also going to be the same. And then we want to have, actually, we can also copy that. It's quite similar to the assets table. So we have a certain symbol, a certain quantity. And then now, in addition to that, we want to know the price that we bought this for. So did we buy it for $5 or for $500 at this time, at this point in time? So column float. And then finally, we also want to have a timestamp, the timestamp being the timestamp where you bought it. So column is going to be date time. And of course, now we can also copy this. And we can also basically copy this like that. Transactions is equal to relationship transaction back populates portfolio. Here back populates transactions. All right, so this is our models PY. This is what we need to model our database. These are going to be our database tables. Here you have the overview. By the way, you will find a link to the code in the description down below, so you can just copy paste it if you want to, or you can play around with it. But yeah, so let's go and create another file here called schemas.py. This is going to be quite straightforward and small. These are going to be our Pydantic schemas. So what does a request, or what do the parameters look like? We're going to say here from Pydantic import base model, and then we're going to just say class user create, which is going to inherit from base model. Is quite simple. A user create will have username and password. By the way, we're keeping stuff simple here, even though it's going to be a comprehensive project. We're going to keep it simple. We're not going to do exception handling for every single endpoint and return everything in a best practice way. It's going to be focusing on a mixture of speed and detail. So user create base model, there you go. Then we have add money. Add money is going to be quite straightforward as well. What this is going to do is it's going to have just amount. We're going to assume everything is US dollars. We're not going to deal with multiple currencies here. And then we're going to say trade asset is also going to be a schema where we say the symbol, which is a string, and the quantity, which is float, as we said. So these are our schemas that have to be validated. And now we get to the main file, the most interesting file, which is actually also called main. So in the case of a FastAPI app, we usually call this main. And in main, we're going to have everything else. So here we get now to the interesting stuff. Here we're going to have all the endpoints, all the helper functions. Now, theoretically, you could also export the helper functions to a utils.py if you want to. I'm going to keep the rest of the code now in this file here. So we're going to start with the imports. We're going to import, first of all, from core Python here, from datetime import datetime. And then we're going to say import requests. Then we're going to say, actually, let's do import JWT first. I always want to have them structured by size. You know, I like the lines to get longer and longer, unless there's a from, then I like to start a new section. Now let's do the FastAPI section here. We're going to say from FastAPI, import the FastAPI class, then also the exception, HTTP exception, and the pence, which is important for the database, or for the database function that we use. Then we're going to say for the middleware, so from FastAPI middleware course, we're going to import course middleware. This is so that the frontend can access the backend without problems. So we allow this type of access here from different domains, which is going to be a different port number. If you have everything with Nginx on port 80, you don't need that. But in this case now, we need that. And then from FastAPI.security, we're going to import OAuth2 password bearer and OAuth2 password request form. That is the FastAPI stuff. Then we're going to say from SQLAlchemy import create engine. This is going to create the database connection. And then from SQLAlchemy.orm import session maker and session. And then finally, we need to also import these two files that we just created. So from .models import base user asset portfolio and transactions. Did I call it transactions? It should be actually transaction. There you go. And hopefully I also called it transaction here. Yeah. Okay. And then of course also from schemas import user create, add money, and trade asset. Now for this to work, we need to create an init py file. Otherwise this is not recognized as a package. So create a new file __init __py. That should resolve the issue if you cannot import these two. There you go. So these are the imports. Now let us create the app. We're going to say app is equal to FastAPI. There you go. That's it. And then we're going to create an OAuth2 scheme so that we have an authentication. OAuth2 scheme is equal to OAuth2 password bearer. Token URL is equal to token. This is going to be for our login, essentially. And then we're going to add the middleware. So we can have these requests from the front end coming in. So we have course. Essentially, I'm not going to do a best practice here. I'm just going to allow everything. This is way too permissive. You want to have in production, first of all, probably you want to use something like Nginx where you don't have to use course. But if you use course, you want to have it as permissive as necessary, not just allowing everything. But to keep it simple here so that it works, definitely we're going to say app.add middleware. And here now we're going to say course middleware, and we're going to say allow origins is equal to everything like this, asterisk. And then we can copy that because we now have also not just allow origins, but we have allow credentials, allow methods, allow headers. So we don't have any problems here for development. Of course, in production, as I said, this is not a good setting. You don't want to have this here. All right, so let us move on to the database connection. The engine is going to be create engine. We're going to keep it simple for this video, and we're going to use SQLite. However, feel free, if you know how to do it, to connect to Postgres. You can set up Postgres, you can set up MySQL. It doesn't really matter, but we're going to keep it simple, and we're going to use a file, and we're going to say SQLite : // and then crypto _ portfolio .db. So that is going to be our file, and then we need some connection arguments here. Connect args are going to be equal to a dictionary, and we're going to say check same threat. We don't want that. I'm going to say false. Great, so that is our engine. Now we need to have a session based on that engine. We're going to say session local is equal to session maker. Session maker, come on. Session maker dot, or actually not dot, calling this session maker auto commit equals false, auto flush equals false, bind is engine. And now the reason we import base up here is because we need to create everything using the base class. So we're going to say base metadata create all, and we need to say bind equals engine. Then what you want to do is you want to set a secret key. Again, in production, a proper secret key. In this case here, I'm going to just say some key, but not this one. There you go. Just some secret key that we're going to use. And now we need our helper functions. These are going to be functions for getting the database connection, for getting the current user, and for also getting a price from the Binance API. So what we're going to do is we're going to say def get db, and we're going to say here db equals session local. And now we're going to say try generating the DB, so yielding the DB here as a generator. And finally, we want to say close the database. And if the database is active, roll back. This is like a typical piece that you see in FastAPI. It's not really specific to this program. This is just what you always find in your FastAPI applications usually. Now the method for, or the function for getting the current user, we're going to say get current user. And here now we need to pass a couple of things. We need to say, first of all, I need the token. So the bearer token, the authentication token, which is a string. And this depends on the OAuth2 scheme. So that is what we need here to identify the user. And then also we want to have a database session. So this is a session and it depends on the function getDB. And once we have that, what we do here is we check the token and we decode it. And we try to see what the user is. So we say try payload is equal to JWT decode. Now to decode the token, only we can decode the token. So in order to do that, the reason only we can do that is because only we have our secret key. So I'm going to say secret key here is used for the decoding of the token. The algorithm that we use here is SHA, I think this is SHA-256, right? I guess. And that is decoding the token. We have the payload, and now all we need to do is we need to get the username out of the payload. So we're going to say user is equal to db query. So we get the username from the payload, and then we look up that username in the database, and we get the user object. So we say user db query user filter, where the username is equal to whatever the username in the payload is. Like this. And in case we have multiple entries, which is not going to happen because the username is unique, but just in case, we get the first element here, and then we return this user as a result of the function call. Otherwise, if there is a problem, we return HTTP exception status code. Status code is equal to 401, which is, I think, unauthorized. Great, so the last helper function that we need now is we need to get the crypto price. So I'm going to say def get crypto, or actually we should probably say, yeah, let's go with crypto, but maybe asset would be better. Get crypto price. But since this is only for crypto, yeah, let's keep it at that. And we're going to say symbol str. And what we want to do is we want to make a call to the Binance API. We want to say try response is equal to requests.get, and now we need to craft the URL. We're going to say https :/API binance.com /API/v3/ticker/price symbol is equal to, and then a placeholder using curly brackets. This should also be an F string in this case. So symbol is equal to that, and then USDT, so that we have like the price of the symbol against the USD tether, so against the US dollar essentially. And here we're going to say this is going to be the symbol. So of course you can feel free to replace that with whatever you want. Maybe you have your own API, maybe you have some paid API that you want to use, but you need a source for the prices. So you cannot just generate them yourself. You need to know what the prices are so you can get them from Binance or from any other source that you have access to. And then we're going to say return float response JSON. And of course, the format differs, but in the case of Binance, it's going to be just the price field. And if there is a problem, we're just going to say return 0.0. Now, theoretically, you could also raise an exception. The problem is that I don't want to raise an exception here because my program is going to, if you use this too often, so if you try to do too many calls in a row, you're going to get some rate limit or some slowdown from the Binance API, so you're not going to be able to send more requests. In this case, it's going to raise an exception because there is no price field. So I don't want the program to crash in this case. It's going to probably happen when I show you the result. So I just want to return 0 in this case. All right, and this is now everything we need to get started with the actual API. Now we go to the endpoints, and we're going to start with our register endpoint. So we're going to say here def register, and we're going to say above that actually at app.post. So this is going to be a post endpoint. It's going to be called /register. What we want to do here is we want to create a new user by using the user create schema. So actually, there you go, user create, and also we want to use, or we need to use the database. So database is going to be session depending on getDB again. Remember, the user create schema is username, password. So we expect these two fields to be here in username, and we use them now to create a new user by saying db user is equal to user, username is equal to user, username, password is equal to user, password. And then we do db add db user, there you go, and then db commit, db refresh, db user, that registers the user. And then we also, of course, every user has a portfolio. In the beginning, it's going to be empty, but we also want to have a portfolio. So we're going to say portfolio is equal to a new portfolio, which is empty, but it has the user ID equal to dbuser.id. Now, this is important. You need to commit or at least flush before you can do that, because otherwise the ID field is going to be empty. It's auto increment. It's going to be automatically assigned. We don't need to do it. But in order to get it, you need to actually commit the user object to the database. And then we also, of course, want to say db add portfolio and then db commit as well. And then we can return some generic message like a JSON object here, message, and the message is going to be successfully created new user or something like this. Now, of course, if you want to keep this professional, you can hash the password, and when you log in, you can hash it again and see if the hashes match. We're now just storing it clear text in the database. Of course, again, one more time, not a good practice. Now, what I want to do at this point is I want to show you, before we move on here, how we can test the individual endpoints, because it's, of course, quite tedious if you, or not necessarily tedious, but it's unsatisfying, I think, to develop all these endpoints and to not know if they work, and only to figure out if they work when you build the front end. You don't want to, you don't know if the front end doesn't work, if the back end doesn't work, and you want to test these endpoints. And in order to do that in this video today, we're going to use a tool called EchoAPI. So EchoAPI is a tool that we can use for testing our endpoints, for testing APIs in general, and they have a bunch of very interesting AI features in addition to ordinary API testing. We're going to talk about this. I need to mention here that EchoAPI is sponsoring this video. However, you don't need to pay for it. When you sign up for it, you're going to get free credits. You don't need to do anything special here in order to use EchoAPI. You can just download it, or you can also use it in the browser and use it to test your API. No cost, no hidden fees or anything. So I'm using EchoAPI here as an application. This is what the application looks like. This is when you download it onto your system. However, you can also use it in the browser. Just go to their website here. Echo API, you can download for desktop. You can also launch the web app. And I'm going to show you the tool. We're going to use it multiple times. I want to show it briefly now, how we can test the register endpoint, whether it works or not. And then I want to show you some more advanced features and what you can do with it. You can do very fancy stuff like just testing your API, or also generating AI generating like parameters and test data. You can also do automatic tests. You can export the documentation, everything. As I said, they're sponsoring this video, so you would help also out the channel. It doesn't cost you anything, as I said. You could also help out the channel if you go and try it out for your own use cases. But now let us see how we can do this. And of course, in order to do this, we need to first run the application. So what I'm going to do now is I'm going to run using FastAPI run main.py. This is going to run the API here now on port 8000. And what I can do now in EchoAPI is I can go and either create a new project or use an already existing project. And here now I can create a new HTTP endpoint. So I can say here, enter URL, and I can say HTTP ://localhost, in this case, port 8000/register. This is now all manual. We can, of course, also do that with AI. I'm going to show you how to do that later on, or at least with recognition as well. So there are many ways to import APIs. But what I can do now easily here is I can say username. Actually, not in the params. I want to do that in the body. I can do that here in raw. I can do that in JSON format. And I can say here username, let's say test user. And then I can say password, and I can say test password. And now what I can do is I can say that this is a post request. This is important. And I can just send this request. And I can see what I get as a result. In this case, I get successfully created new user. As you can see now, I provided this request and I got the message successfully created new user. We're going to explore other features in more detail when we get to the testing. As I said, what we're going to do is we're going to develop the API, then we're going to test it to see it works. Then we're going to move on to the front end. But this is a basic use case. We can do stuff like pre-request scripts, post-response scripts, and we have a ton of AI features, and we can export the documentation easily. We're going to take a look at all that, but this is just a quick showcasing of the feature, of the very basic feature of just testing a single endpoint. We're going to take a look at this, as I said, later on again. All right, so we have this done. It seems like it worked. We can also see if the user is part of the database. So I can go SQLite crypto portfolio, actually SQLite 3 crypto portfolio, and then I can say, what was it, tables, select everything from users. There you go, test user, test password. Perfect. Now let us go back into our application, main.py. And let's implement the other endpoints, and then we can go into the testing. So registering is done, and now we want to do login. A login is also a post endpoint, so app.post/login. And here now we need to provide the correct credentials, so some of the credentials that are in our database, and then we need to see if that is correct. And then we need to provide a token. This token is going to be the basis for all other endpoints. So we're going to say here def login. And we're going to say form data is the login data. So this is going to be our OAuth2 password request form, which contains a bunch of fields, but importantly, it contains also username and password. This is going to be depends empty, and then DB session is going to depend again on the getDB function. There you go. So that is our login endpoint. And here now we're going to say get a user from the database that has the password, and or actually get a username, get a user from the database that has this username, and see if the password matches. So say user is equal to db query user filter user.username is equal to form data username. And we want to get the first one since it should be only one. Then what we do is we say if not user. So if a user like this does not exist, or user.password is not equal to form data, user.password. So either the user doesn't exist or the password doesn't match. In this case, we're going to raise an HTTP exception, which is going to say status code 400. And we're going to say user, or let's say information invalid. This is quite general, whatever the problem was. And then we're going to say, otherwise, we're not going to raise the exception. Otherwise, we're going to generate a token. The token is the JWT, JSON Web Token, that we generate within code. And what we do here is we say username is user.username. We do this with our secret key, and the algorithm is again HS256. So this just means if the login is successful, we generate a token that only we can generate with our secret key, and this token contains the information which user it is. So basically the username of the user. And what we do here now is we return a dictionary object, access token, and then token underscore type is bearer. That's important, so we know that this is a bearer token, and we can then use that for every other request for every other endpoint. So let's move on to the add money endpoint. We're going to say app post add money. This is going to be where we just load the fictional dollars into our account. So we're going to say here that is the add money endpoint. It's going to get money, which is going to be our schema add money. Remember, we had the schema add money, which was just an amount. Now, theoretically, you could also just say float. It's fine. But yeah, we're going to use a fancy schema here. Then we're going to say user is a user, depends on get current user. Now, this is important. This only works now if we are authenticated, because only then can we decode the token and see user is username. So the user is going to depend on the token. Authentication is necessary. And then we're going to say DB is session and depends on get DB. There you go. Let me just close that. And here now what we're going to do is we're going to get the portfolio of the user. We're going to get the total added money and the available money, and we're just going to add money to this account. So we're going to say portfolio is equal to, actually we don't need to do DB query, we can just say user.portfolio. This is now why we have the relationships. Go back to the models PY and you will see we have here the user has portfolio as a relationship. So this essentially means that I can access it like this. It's an attribute of the object. And now I can say, what I want to do is portfolio.total, or what did I call it? Total added money plus equals money dot amount. And then the same for the available money, because the money that we add is going to be available money. And then finally, DB commit and a simple message saying successful. So message successfully added money. Great. Then what we want to do is we want to buy and sell assets. These are the two, I would say, maybe the last three functions I would say are the most comprehensive ones. I wouldn't say they're complicated, but they are, yeah, they have a logic to them, let's say. So we're going to say app.post/buy. And here now we're going to have the trade asset schema. Remember one more time, we have here symbol and quantity. So we're going to say def by asset. And it's going to be our trait. So trade asset schema. User, same as before, depends on get current user. And then DB session depends on get DB. There you go. So here now what we do is we get the portfolio, we calculate the price based on the Binance API, we calculate the cost, we check if the cost is higher than the money we have available. If it is, we raise an exception. Otherwise, we perform the trade, we add it to the transactions, and we commit everything to the database. And we also make sure that we subtract the money from our available money, which is not the total added money, just the available money. So we say again, portfolio with a lowercase p is user.portfolio. And we say price is equal to get crypto price. This is now the Binance request. So this will be something that you don't want to run too often, probably, unless you have some better API. And what we want to do here is we want to trade symbol. So we want to buy, or we want to get the price for the symbol, BTC, for example. And then we want to multiply the price by the amount. So we want to say total cost is price times trade dot, was it quantity or amount? I think it was quantity, right? So that is our total cost. And we want to check now, is this total cost above what we can afford? So is it more than portfolio available money? If it is, we raise an HTTP exception. Status code is equal to 400, and the detail is insufficient funds. And otherwise, what we do is we get the asset. So we say the asset is equal to db query asset filter asset dot portfolio ID is equal to portfolio dot ID asset dot symbol is equal to trade dot symbol dot first. Now, of course, you recognize not always will I have traded that in the past. So if the asset exists, which means that if in my portfolio I have that asset already, I just have to add the quantity. If I don't have it in my portfolio already, I just create a new asset and add it to the portfolio. So I say if the asset exists, then I'm going to say asset.quantity plus equals trade.quantity. Else, we say asset is equal to asset portfolio ID is going to be equal to portfolio.id, so we add it directly. The symbol is whatever the trade symbol is. And the quantity is whatever the trade quantity is. And then we say db add asset. All right, and of course now we need to also subtract the money from our funds. So we need to say portfolio dot available money minus equals total cost. And maybe before that, just to have it in the correct order, we also want to have the transaction. So we're going to create a new transaction now. We need to lock all the transactions. This is going to be a transaction of the portfolio, or with the portfolio ID, portfolio.id. Let's keep it consistent here with the spaces. Then the symbol that is being traded, of course, is still trade symbol. Then the quantity is trade.quantity. And then the price is equal to price. Timestamp is just datetime.utc now. So the current moment. That is the transaction. Now, of course, we also need to add that transaction to the database. And finally, once we have done that with a portfolio as well, what we do is we say db commit. And finally, we return the dictionary containing the message that asset successfully bought. There you go. So that is our buying logic. Again, to repeat that, portfolio is being loaded. We get the price of the symbol. We get the total cost. We see if we can afford that. If yes, we see if the asset is already in the portfolio. If yes, we just increase the quantity. Otherwise, we create a new instance. We definitely lock the transaction. We subtract the money that we expended from the available funds. There you go. We have an asset that was bought. Now for the selling endpoint, we can actually copy the buy endpoint and change a couple of things. So first of all, we want to say sell. Then we also want to say sell asset. Then we also want to say, we don't need to price in the cost right away. First of all, we want to do a check. So let's say portfolio, and then we want to get the asset. So we want to say asset is equal to db query, because what we want to check in this case is, do we actually have the asset, and do we have enough of the asset to perform the selling operation, the selling trade. So we say asset filter, and then asset portfolio ID is equal to portfolio.id, and asset.symbol is equal to trade.symbol. And then we want to do a different check, not this one. We want to say, first of all, do we have the asset in the first place? Or maybe let's do it in negative. If not asset, if we don't have the asset, or the amount is not enough for what we're trying to sell. So if the asset dot quantity in our portfolio is less than the trade dot quantity, then we have a problem. Not enough to sell, let's say. Insufficient assets would also be a good message here. So price, we still get the price. Now let's call this value, since it's not a cost, total value that we're selling here. And then we want to see, or we don't want to see, we don't need that. We just want to say asset.quantity minus equals trade.quantity. So we sell that. And then we say if the quantity reaches 0 by doing that. So if that is 0, we want to delete the asset. Delete asset from the database. Now the transaction is going to be here as well. So we're going to say transaction portfolio. Actually, we can copy this here. So I'm going to just say transaction copy like this. And then we're going to say db add transaction. And down below, we want to also say quite similar to before, so we can delete all of that. Available money plus equals total value. db commit, and assets successfully sold. So finally, we want to have our endpoint for tracking the portfolio performance. What is the state of the portfolio? What does it look like? And for this, we're going to say app.get. This is our only get endpoint here. Portfolio. This is also going to depend on all these things. So we're going to say here def get portfolio. Also, as the other endpoint is going to depend on a user, who is a user, depend on get current user, and db session depends on get db. And now we can retrieve all sorts of things and calculate all sorts of things. We're going to say portfolio is equal to user portfolio, and then assets response, so that we see all the assets here, is going to be an empty list, and then total value of the portfolio is going to be the portfolio dot available money. And the reason we start with this is because we're now going to iterate over the list of assets. So we start just with a cache that we have and with an empty list for the assets. Now we're going to iterate over the assets and add to the total value into this list. So we're going to say for asset in portfolio.assets. This is again a relationship that we're using here. Remember, we have here, where was it? Assets. So this is the collection here. And now we iterate over that and we add the respective values. So we say here current price of an asset. This is of course always a snapshot of a moment because the asset prices fluctuate. So we're going to say the current price is get crypto price for a given asset. So for asset dot symbol. And then we need to of course say net quantity is equal to asset dot quantity. For the asset value, we're going to say that it is equal to current price times net quantity. Then we're going to say for the total value, this means plus equals asset value. Now for the transaction list, we're going to say transactions is equal to DB query transaction. And we're going to filter where the transaction dot portfolio ID is equal to this portfolio, so to portfolio dot ID, and also where the transaction symbol is the one we're looking at, so where it's equal to asset dot symbol. That is going to be that, and we're going to do this here for all of them. So we are not just interested in the first one, we want to have all the transactions. This is going to give them to us. Maybe let me zoom out one level here. There you go. And now what we want to do finally is we want to append for each asset here, for each of those, we want to add here to the assets response the performance. So we want to say here assets response is equal to, or actually not equal to, sorry, append. We want to append a dictionary, and this dictionary is going to have a couple of fields. It's going to have the key symbol, obviously, which is going to be the asset symbol. We want to have a quantity, which is going to be the asset quantity. So that's the basic stuff. I don't like the auto completion when I have a new line after a comma. Then we have the current price. So what it currently looks like to see when we made the respective transactions, or to compare it with the respective transactions that we made. So current price is going to be just the current price. Then we're going to say here total value of that asset that we have is going to be the asset value. And then the next thing is going to be the absolute performance and the relative performance. So the performance apps, so the absolute performance is going to be the asset value minus the, actually we didn't have that. We need to also say the net cost here. So the net cost is going to be equal to sum of t.price times t.quantity for t in transactions. And that is what we subtract here from the performance absolute. And then finally, the performance relative is going to be asset value minus net cost divided by net cost times 100 if the net cost is not equal to 0, obviously, else 0. That is our response object. So this is what we're going to return here. And besides that, now we only need to return the general portfolio information. So return is going to be also a dictionary. We're going to return here the total added money. Portfolio.total added money. Then we're going to have the available money, which is the portfolio available money. Then we're going to have the current total value of the portfolio, which is going to be the total value. Then we're going to have the performance absolute and relative in terms of the portfolio. So we're going to say performance absolute is going to be the asset value, not the asset value, sorry, total value. So we do the same thing as here, but we do it for the whole portfolio. So total value minus portfolio added, total added money. Because if I added 10,000 and now I have 15,000, I made 5,000 profit. And then I just need the relative performance metric here. So performance rel is going to be equal to total value minus portfolio dot total added money. So basically the absolute performance divided by the portfolio added money. Total added money times 100 if this is not 0 again, so portfolio dot total total added money, if that is not equal to 0, else 0. Great, so that is it. And finally, I forgot one more thing, which is the assets is going to be assets response. That is our backend. So this is now done. We can register, log in, add money, buy assets, sell assets, and get the portfolio metrics. And now what we want to do is we want to test this. We're going to use EchoAPI, as I said, to test this. So this wonderful piece of software here. And we're going to use that to test this. We're going to automate certain tests. We're going to write certain tests ourselves. We're going to also automatically take these endpoints now and read them into EchoAPI. Then I'm going to show you some of the AI features, and then we're going to also see how we can export this for a nice API documentation. Use case for this would be you develop this as a backend engineer, you pass it to a front-end engineer. He already has a proper documentation, can start working with it. And this is what we're going to see how to do now. For this, let us go ahead and run our API. So FastAPI run main.py. There you go. And then we're going to go into our browser. We're going to type the following: localhost 8000/openapi.json. That is going to give us a JSON of our API that is generated by FastAPI. So I can go raw data here, and I can just copy paste all of this, or I can just download it. This is also possible. And I can just store this now in my current directory, OpenAPI JSON. And now I can go back to EchoAPI. So I'm still going to use the desktop application here, but what we can do now is I can delete this, for example, and I can say now import. So I can say create, and here now I can say import. Now we can do a bunch of things here. One thing that we can do is we can do AI intelligent extraction API documentation, which means, let's say this is not your API, you only have a documentation for the AI, so you don't have the code, you don't have the JSON file. What you can do is you can just copy paste some description of the API endpoints here, and EchoAPI with the AI features is going to take that and import it from that documentation. However, you can also import the entire file. So you can say other file import, you can say Swagger, and we can go to the current directory, and I can go with the openapi.json. And there you go, we have all these endpoints here now loaded. I can confirm that. Then I have to click on import now, and then this is imported into EchoAPI. I can go then to the APIs, and here I have now all my endpoints: register, login, add money, buy asset, sell asset, and so on. All this is part of my EchoAPI setup here. And as you can see, I can also go, for example, to register, and I can see here already username and password. Now, one thing that is offered to me here is one-click completion. So you can see here, smartly refine and complete the API documentation, which means like the design here where we describe the endpoint. So we can here add documentation to turn this then into a nice fully documented API. So I can fill out the entire documentation here by clicking on this one-click completion. However, for this to work, one thing is important. You can see here the endpoints are just /register, /login, and so on. We have all the correct fields loaded, but we need to also provide here that the URL of our project is localhost port 8000 because it doesn't know that yet. So basically what I have to do is I have to go up here to default environment. I have to go to new environment. Then I can actually go to default environment and change here the base URL of the server. So I can say here http://localhost 8000 save, and then save and close. Then I can go back to my register API here. You can see now it's http localhost/register. Now I can click on the one-click completion, and you can see now that this will start a process of completing the request parameters. So you can see here username John Doe, password 123. Then it completes the response parameters. It properly names the API endpoint. All of this done using AI. I'm not doing anything. And not only does it document this, but it also provides reasonable data. So I don't have to set anything up myself. I can just complete everything. Then I can say save. And you can see now all of this is done properly. Now I can just say send. And hopefully I will get the response that this was done successfully. There you go. Now, one more thing that I can do is I can test this endpoint by going to cases, and then it's providing me here AI-generated tests. So I have API specification compliance test, HTTP method validation, I have rate limiting tests. I can just say generate test cases, and then the AI is going to do all the test generation here for me for these couple of use cases here. It shows me what it wants to do here, and basically I can then just say apply and test, and it's going to apply and run these tests. But let us focus now on testing our functionality. What we want to do is we want to register a new user. So we want to go here back to the debugging. We want to create a new user, which we have done here. Then we want to take these credentials. We want to log in with them. We want to get a token. We want to use that token for all the other endpoints. So we can, of course, do that manually every time, which is kind of tedious. So manually would be, for example, I go and copy John Doe and password 123 and exclamation mark here. I go to this part here, John Doe, password 123 exclamation mark, and I can try now to log in, send. Oh, we need to provide the grant type password here, but then I can just send. And in this case, I get an internal server error, which is interesting. This seems to be an error in my code. Now you can see, okay, my code doesn't work as expected. This is something I figure out by using this tool. And this is exactly now in line 77 in main py, which is here. User is equal to db query user because we didn't pass a user, it seems, right? Oh no, the problem is that we didn't specify uppercase user here. So let's try this again. Let's log in with the same data. The registration worked anyways. Now I get another error. JWT has no attribute in code. Okay. Okay, the problem here is that we have the wrong package. So we need to say pip3 uninstall JWT. I already did that now in my case. So pip3 uninstall JWT. What we want is pi JWT. That is the package. Actually, I don't want to uninstall that. Sorry. I want to install that. So pip install pi JWT. In my case, this should already be satisfied. That is the correct package, so I had the wrong package in the beginning. Now let's do again FastAPI run main.py. Let's go back here, and now hopefully it works. There you go. As a result of that, I get the access token, and now I would have to use that in the header of every other endpoint. So what I can do here instead is I can do something called post-response scripting. So I can take that output, and I can write a script that takes that and then stores it into a variable, and I can use that variable later on. So I can say here add task, processing script, and then I can add some very simple code here, which says let response equal to pm response.json. And then I say pm globals.set access token, and now I can set the field from the response. So response.access token. That is the access token, and now I can say that, I can log in. This is going to be stored then as a result of that, and then I can go to something like add money. And here now either I can use a pre-request script where I can show you the code, where you can do something like pm.set request header, and then I can say authorization, bearer, and so on. But what we can also do, I think this is simpler, is we can go to the headers directly, and we can say here authorization, and I can say as the value here with 2 curly brackets, I can go with access token. However, not just access token, but bearer access token. Now, of course, we also have to pass an amount. So let's go with 200 or 2000. Now we get an internal server error, which is HTTP exception has no attribute portfolio. Okay. Yeah. So we cannot get the portfolio object here because the decoding failed. Oh, I see. There's the problem identifier response has already been declared. So let's call this resp, not response. So let's say resp. And then maybe it will work if I do it like this. So just save that and run this. And then we get the token. And then when I go to add money, if I go to the headers, now it works. Okay, there you go. Bera access token, and then pre-request here is optional. You don't have to do that now. But now we can do the adding of money. So 2,000, let's go with 20,000 actually sent. Now I still get a server error. So maybe there is an exception here which I need to handle. So let's go to the get user function. What we do here is we just do all exceptions. So whatever happens here is somehow resulting in an exception. WQ, and then FastAPI run main.py. Let's see what happens now. What I get is key error payload. Yeah, obviously. I mean, what the hell am I doing here? Of course, this is not payload, but username. So it would be username. All right, I think this should now work. Let's go back. Let's run this. And now we get successfully added money. Perfect. So we can do the same thing now here. Let's do it for the other ones with the pre-request. We can go here and we can say add task, processing script. And then again, let me just copy paste this now because I don't want to type it again from scratch. Just like this, authorization, Bera, globals, get access token. And we're going to say by 0.2 Bitcoin. That should be possible. Insufficient funds. Okay, maybe it's not possible. 0.01 Bitcoin. Asset successfully bought. So we can now take that pre-request script and add it everywhere. So I can do it here as well. And then I always have my tokens. And the cool thing is I can also save this and I can say, give me now the portfolio information. There you go. We can see the transactions. We can see the performance. We can see the total value, the total added money. So we lost some money. Of course, we have no transaction cost here, but we still lost money because the current price is not the same as the price when we bought. But yeah, that's basically that. And sell asset, let's see if we can do that now as well. Let's go to body. Let's say BTC. And let's say 0.005. And asset successfully sold. Let's go to portfolio again. And now we can see also that we locked in that trade basically. And we only have 0.005 Bitcoin left. By the way, another very useful feature is the test cases. What you can do here is you can create a new test case. You can call it whatever you want. And then what you can do is you can make requests. Then you can add an if statement. You can add a script. You can make assertions. You can do loops. So you can basically program test cases that include calling multiple endpoints and also connecting their output. So for example, here I have prepared the adding money test. What it does is it registers as a new user if you haven't done it already. So you can always enable and disable these. In this case now, the first time I run this, I create a new user called test user, test pass with a password here. And then what I do is I log in, I save the token to the globals. Then for get portfolio, I load it from the globals here and I set it into the header. Then I get the total amount of money added. Then what I do is I store that into the globals as the old money, as the old total money added. Then what I do is I call add money with 20,000, I think. And then what I do is I get the value again. And in the end, I have a test case here, PM test, that the old value plus 20,000 is equal to the new value. And essentially what I can do now is I can save that down here behind my camera. Maybe I can move it a little bit here. You will see this run button, and this run button basically then executes all the tests. And I'm going to see if all these requests succeed. This is actually sending requests to my server. And if something goes wrong, I'm going to see why. I'm going to see the status code. And in this case now, let me just move this here again. We can see I logged in successfully. I got the portfolio successfully. This script was executed successfully. There's nothing here. I added money successfully. I got it again successfully. And then in the end here, you can see the test case also passed. So this is also super useful. You can create these automated test cases where you can simultaneously test multiple endpoints. Now, one more thing that I want to show you is once you're done with all the design stuff, so once your API is fully documented with everything here, you can do that, as I said, with AI. We can also export the documentation. So once you have documented all your endpoints like this, what you can do is you can, for example, save and preview, or you can also just share. So in this case, this is the preview. I can say now share, and this is going to show me also a preview. That is the documentation. You can see username string, password string, what it looks like. I can of course manually adjust stuff here. I can use a logo and so on, and then I can just open the documentation, export it, share it to people, whatever I want to do. In this case now it looks like this. There you go. That is my exported documentation. You can do that easily with EchoAPI. You can add your own logo and so on, but that is a quite nice tool. So with all that now, with the backend working, with EchoAPI used to test it, by the way, again, check out the link in the description down below. You get free AI credits with EchoAPI. They're sponsoring this video. Make sure to hit the link to download it, play around with it, test your API with it, test the AI features. I think it's a really cool tool. And this is the first step. Once you have your API tested, once everything is done, what you want to do is you want to go now, or what we want to do now is we want to go into the front-end development. All right, so you know I'm not the biggest fan of front-end development, which is why we're going to use Cursor for this section here, just so we can get it done quicker. You will find all the code in my GitHub with a link in the description down below. But we're going to just create now a new directory here, a new folder, call it front-end, and here now we're going to create a React application. So what we can do with that is we can open up a terminal and we can go to frontend, and then we can say npm. Now, of course, for this, you need to have npm installed. I assume you have that or you know how to do it. Create vite and then add latest. And I'm going to go with dot for the current directory. So it's going to install the following packages. Yes, that's fine. I want to go with React. I want to go with TypeScript. And that's basically it. We have our setup in this directory. So we're going to now use Cursor to build our front end based on the back end. For this, I'm going to create a new folder here. I'm going to call it service or services, like this. I'm going to create a new file in here. I'm going to call it api.ts. And I'm going to say now in Cursor, in addition to the api.ts file, I want you to use as context here the file from the backend called main.py. So main.py from the backend here. And then I want to say provide all the code for the api.ts to work with the backend. It will be running on localhost port 8000. So I can run this now. I will get my functions here to connect with the backend, and we're going to discuss them. I don't want to do some like just vibe coding here, but I want to show you that yeah, I don't want to type everything out. Let's put it that way. So we have here the interfaces. These are basically matching our database structure and everything. And then we have here the API client setup, and then we have the auth token, the register, login, log out, which is just removing the token, adding money, buying assets, selling asset, getting portfolio, and that's basically it. So that is now our service layer here. Next, we're going to create a directory here called components. So I'm going to say new folder components. And this components directory will have 3 different files: register, tsx. Then I will also say login, tsx. And then I will also say dashboard or main interface, tsx. And then what I want to do now is I want to say new chat. I want to add as context here the API TS, and I want to say provide the full code for the register TSX, make it look nice using Tailwind CSS. I'm not sure if it's going to be able to install that. Otherwise, we have to do it manually. There you go. Looks good. Accept. We're going to see if it works or not. Then it goes for the package JSON and sees if it has to add the router, which it has. So we need to do that. Run the command npm install Axios React router. And it should also probably install Tailwind. I hope so. Even though I didn't ask for it, it also implemented the login TSX, and it also installs Tailwind now, so I can run that. Seems like it just implements my whole project. We're already in the front. Okay, yeah, it ran the wrong command. Okay, so it's done, and everyone who thinks they're a front-end engineer should be looking for a new profession, I guess. Maybe it doesn't work, but I got the register TSX, the app TSX, even though I didn't ask for it. So let's accept all of it. It installed hopefully everything correctly. Now the only thing missing is the dashboard. Here now I need to provide more specifications. So I need to open up a new chat. I'm going to also provide the API TS, the app TX, and let's say the login TSX, not TX. And then we're going to say here, implement the full dashboard. I want to be able, and then once logged in, to see all my assets, to see the performance, to buy new assets, to sell assets, to add money, and to log out. Make sure everything looks good. Make sure all positive performance numbers are green and all negative are red. Let's run this, and if that works, we have a front end. So the reason I'm doing this is, in Cursor is for multiple reasons. First of all, the video is already quite long. Second of all, my channel is focusing on backend development, AI, and so on. So front end is of course an important part, but I can show you here using this example that front end is not the critical part of the application. It needs to look good. I don't like making it look good. I don't like spending time coding React and HTML and CSS stuff. So I'm just gonna let it be generated. If there are problems, I can just troubleshoot them. The main logic here, the main interesting part, all happens in the API TS, but all we do here is we just call the endpoints and we define the schemas. Maybe the only interesting stuff is the auth token and the login here. So with the authorization, the bearer token, same thing we did in EchoAPI, and here now also with the content type with the URL encoded, and with the form data that we append here, username, password. But that's about it. Okay, so it's done with the generation. Let's look at the dashboard. Let's accept everything. This is quite a bit of code, which I wouldn't have wanted to write myself. There you go. And now we're going to see if this works first try. I didn't even read or I didn't even look at the code. Let's go to our current working directory. Let's do in the backend here FastAPI run main.py, and then let's go to the current directory again, to frontend, and here npm run def. And let's see now if I go into the browser, I get a problem, which I thought I'm going to get the Tailwind problem here. As you can see, there's a problem with the, looks like you're trying to use Tailwind CSS directly as a post CSS plugin. So maybe let's just try to pass this to Cursor and see if it can do something about it. Okay, I think I'm going to stop this because it doesn't seem to realize that it has to be loaded in Vite. So we basically need to say here Tailwind CSS. And we need to, of course, I mean, it was suggested here. There you go. Tailwind CSS. That is what needs to happen here. But the import has to be at Tailwind and then Vite, like this. And we also want to run a different command. We want to go here to frontend, npm install Tailwind CSS, and also Tailwind CSS Vite, We also don't need the post-config CSS. Let me just move these terminals to my other window. We don't need that. We also don't need that. And now in our index CSS, we want to do add import tailwind CSS. All right, now it seems to work. So it seems like it doesn't perform as well as a human programmer, but it did a lot of work for us. So the setup of Tailwind TSS was a bit tedious, but now you can see I still have the portfolio overview. We have the available cash, total added, performance. Now I can see total cash is this. So let's buy an asset. Let's say, I mean, okay, it says Apple. It should be crypto, but let's go with ETH and let's go with 2 ETH. Buy that. Now, I noticed one more thing after recording, because I didn't pay attention while I was explaining, that these numbers here can't be correct because we have a massive negative performance. This is a wrong calculation because a problem happened when I copy-pasted the logic for selling and buying because we're treating them as the same type of transaction. What we need to do is we need to go into our code, into the backend code, into the main PY file. And here now in the selling logic, as you can see here, buy asset transaction and sell asset transaction are the same. Here we need to have a negative quantity. So we minus trade quantity is what we actually buy here. So we buy a negative amount, we sell it. And here now for the calculation, we need to also say for the net cost, we're only going to consider buy transactions. So buy transactions are going to be transactions where the quantity is negative. So T for T in transactions if T dot quantity is greater than 0. So actually only positive ones. So we're only caring about those where we buy something, so where the quantity is positive, because that means that we pay money to get some asset. And the net cost now should only be based on that, so only on the buy transactions. Now, of course, this is not going to fix the problem we already have with this user because he already has the transactions. But for any new account, this should no longer happen. So I can actually go, I can restart the API. So here now I should have, here I can see restart. And then I can go into the browser, or actually I already am in the browser. And maybe I can create a new account here, register, test user, or let's say neural 9, neural 9, neural 9, register, sign in, neural 9, neural 9. Failed to load portfolio data. Oh, also another problem here that I just noticed is that we need to remove the parentheses here because it's basically that divided by that, else 0, not divide by 0 if that is 0. It doesn't make a lot of sense. So that should work. And now let's go back to this here. Let's restart this. Let's go to our browser and restart this. There you go. Add money. Let's add 100K. Now let's try to buy an asset. Let's say BTC 0.5. Buy. There you go. I have now this. This is the current Bitcoin price, and I can buy half a Bitcoin now, and I can reload the page. Hopefully, I'm not going to be banned from the Binance API. Now you can see I have positive performance. Now I can also buy a little bit more. I can say BTC 0.01. Buy. That is also going to be added now on top of that, and then I can also do something like buy Ethereum 0.02. There you go. And then I can also sell something like 0.01. Bitcoin 0.01. Okay, but this still doesn't make sense. We're losing money when we're selling, so we need to change something here again. Let's go into main PY. And let's go and When we do the calculation, we don't want to just go with the performance immediately. We want to first calculate an average purchase price. And for that, we need to keep track of these things above here. Total cost equals 0. Total bought equals 0. And then for transaction in transactions, let me zoom in a little bit. If t.quantity is greater than 0, then it's a buy transaction. So we say total cost times equals actually the t quantity times the t price. And then we're going to say total bought is just plus equal t.quantity. So then the average purchase price is going to be equal to the total cost divided by the total amount of shares bought, if that is not 0. Or not shares, but currency, asset, quantity, whatever. So total bought if total bought not 0, else 0. And now we can say the invested amount is the average purchase price times the net quantity. And now we can replace our calculations down here by not using net cost, but by using invested amount. So we say asset value minus invested amount, and here as well, invested amount, and here as well, invested amount, and here as well, invested amount. And we can also provide the average purchase price here. All right, so let's see if that works. Let's go to this here again. Let's run it. Let's go back. Let's go to the browser. Now again, here we're not going to see, actually we can see the performance difference. Now the problem is it tells me that I made 50K. Oh, all right, I found a stupid mistake. It was in this line. It's not times equals, it's plus equals. Otherwise we stay at 0 and that messes up our code. So let's rerun this again. Now in the meantime, I tested a little bit. So I now have a new user here, which I played around with, but now you can see it works. Okay, now it works. Now we can go again from scratch, register. Let's call the user XYZ. Let's call the password XYZ, 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 XYZ. There you go. Now we have an empty portfolio. Let's go add some money. Let's do 200K, add money, buy asset, BTC1. Now we can see, okay, this is what the performance looks like. Now let's buy ETH 1.5. And now we can track the performance. Now I can also sell an asset. So let's sell 0.5 ETH. And now our performance doesn't look absolutely crazy. So yeah, this is now the proper implementation. Again, you will find the link in the GitHub repository, which is linked down below. So that is how you can do that. Of course, what you can do now in Cursor when it comes to the styling is you can say just change this in terms of make it a dark mode and add new buttons or add something else. But overall, this is a pretty cool trading dashboard. You can also try to chart something here with some library. But yeah, this is how you can build a full crypto tracking tool or a full crypto demo portfolio in Python and React and test it with EchoAPI. So that's it for this video today. I hope you enjoyed it and hope you learned something. If so, let me know by hitting a like button and leaving a comment in the comment section down below. Also, as I mentioned a couple of times already, don't forget to check out EchoAPI, the sponsor of this video today. That is the tool that we use to play around with the API, to test it, to check it out, to experiment with it before we had the front end. This is a professional important step to check the API. They have a lot of interesting AI related features, a lot of interesting programmatic features, and it's completely free. You even get 50 AI credits for free. So make sure you check them out. And other than that, thank you much for watching. See you in the next video, and